In this video, we will explore two spatial interpolation techniques, inverse distance weighting and the modified normal ratio method. We will solve the same example which was discussed in earlier two parts in GeoGebra. Both these methods require distance from each index station to the target station. Here, D1 is distance of index station 1 from target station X. Similarly, we can define distances D2, D3 and D4. Modified normal ratio method require normal precipitation values at index stations in addition to distances. First, let's examine inverse distance weighting method. IDW assumes that neighboring stations closer to the target station exert a stronger influence on its rainfall depth. Px is estimated as summation of Zi Pi, where I varies from 1 to m, over summation of Zi, where I varies from 1 to m. The weighting factor Zi for each index station is inversely proportional to the square of its distance di from the target station. Let's go to GeoGebra. We can rewrite the formula for estimation of Pa so that we can observe the weights in GeoGebra. We will change the distances using sliders and will observe its effect on the weights and Pa. Initially, let's keep all the distances as same. We can see the weights are 0.25. These weights are same as arithmetic mean method, and estimate of Px is 9.85 millimeters, which is also same as arithmetic mean method. Notice how the influence of station B increases as we move it closer to the target station. This is indicated by increase in weight of index station B from 0.25 to 0.46, and rest of the weights become 0.18. This means that precipitation of station B has more influence on estimate of station A than the rest of the stations. Additionally, if we change distance AD to 5 km, both index stations B and D have equal weights, as both distances AB and AD are same. In summary, we can think IDW as improvement over arithmetic mean method. This method is applicable for plain areas. If surrounding stations experience significantly different long-term precipitation due to elevation or microclimates, which means normal rainfall of neighboring station will be different, modified normal ratio method is good option. MNR combines normal ratio with IDW weighting method. It incorporates each index station's normal annual precipitations as well as distance weighting factors. Px is estimated as nx summation of Zi Pi by Ni, where I varies from 1 to m, over summation of Zi, where I varies from 1 to m. Let's visualize MNR in GeoGebra. We will use the same example which we did earlier. We will use these sliders for changing distance and these sliders for changing normal ratio. At first, we can keep the distances same. We can see that the weights of each index station and estimate of Pa are exactly same as normal ratio method. Now, if we change the distances, we will get new estimate of Pa, which is unique to MNR. Let us summarize. Inverse distance weighting method is better than a plain average because it trusts nearby weather stations more. The closer a station is, the more its data matters. Modified normal ratio is better pick for mountains and uneven ground because it looks at two things: how close the station is and how much rain that area usually gets.